Hello, everyone, and welcome to another math lesson with Miss U. Today's lesson is all about scientific notation. So, before we move on, please make sure you have a pencil or pen with you and a sheet of paper that you can write on. So our I can statement is I can convert numbers between scientific notation and standard form in order to understand and explain why scientific notation is used to express very large or very small quantities. And that is the standard 8EE3, which deals specifically with that I can statement. All right, so we do need to get accustomed to some vocabulary in order to understand scientific notation, and the first one is scientific notation. Now, scientific notation is simply a special way of writing numbers like this, which is 700 or 7 times 10 to the second power, or this, which is 4,900,000,000, which is easier written as 4.9 times 10 to the 9th power. We also want to know what standard form means. And standard form easily is just not in expanded form. So examples of standard form are 700 and 4,900,000,000. And the last vocab word is power of 10. And I'm just going to give you examples of power of 10. The first example is 10 to the second power, and the second example is 10 to the 9th power. So a power of 10 is simply an exponential expression that has a base of 10 and an integer exponent. How to write numbers in scientific notation. Now, when writing a number in scientific notation, you always need to make sure you have two parts. The first part is a number between 1 and 10. So this we like to call the factor. It can also be called the coefficient, and if you want to level up your vocabulary and speak on a college level, you can call it the mantissa. And then we have the second part, which is an integer power of 10. So any exponential expression where you have 10 as the base and an integer as the exponent. And here's an example. So if I have 4.5, that would be the first part of my scientific notation number, and times 10 to the 5th power shows me the integer power of 10, and this is a number in scientific notation. So let's take a look at converting numbers from standard form to scientific notation. So here are two examples, and let's just look at the first example. It says the temperature at the sun's core is approximately 2 million degrees Celsius. Express this number, this temperature, in scientific notation. So my first step is to place a decimal, and you can see it right here. Place a decimal on the number if there is no decimal currently visible. And when you have a whole number, the decimal always goes at the end. Now my second step is to move that decimal, all right? And moving the decimal is going to inform me about something. So I'm gonna move that decimal 1, 2, 3, 4, 5, 6 times. I move the decimal until it is in a place where my number is between 1 and 10, as we saw before. So now I have moved my decimal 6 times and created this number 2 in the front. So the beginning of my scientific notation number is going to be 2 or 2.0. And then my power of 10 is going to have an exponent of how many times I moved that decimal, 10 to the 6th power, right? And if I move the decimal to the left, which I just did, that means my power of 10 will be positive. Pause the video now and copy this into your notes. Now let's take a look at the second example. The second example says the average weight of a common ant is 0.0003 grams. Express this temperature in scientific notation. That is an obvious typo. I don't mean temperature, I mean weight. So let's express the weight in scientific notation. Same steps. Step 1, place a decimal if it's not already there. But hey, take a look. We have a decimal right here. Second step, you want to move that decimal until you have a number between 1 and 10. So how many times do you think we're going to move the decimal this time? Let's see if you're right. 1, 2, 3, 4. We moved it 4 times because now, after moving it 4 times, we have that number 3 or 3.0. Now I want to write the second part of my scientific notation number times 10 to the what power? Is it going to be the 4th power? Not this time, right? Because we moved it to the right and we started with a smaller number, it's going to be 10 to the negative 4th power, all right? Because if you move the decimal point to the right, then the power of 10 will be negative. Pause the video now and write that into your notes. So that is going from standard form to scientific notation. Now we're going to do a little switcheroo and go from scientific notation to standard form. So convert the following numbers in scientific notation into standard form, starting with 3.2 times 10 to the 3rd power. So I'm going to first start by taking my factor, or my coefficient, or the college level term, mantissa, and I'm going to rewrite it, and then I'm going to look at my exponent, right? My exponent is 3 and it's a positive. When my exponent is positive, it tells me how many times to move the decimal to the right. So I'm going to move my decimal to the right 3 times. Let's do it. 1 time, 2 times, 3 times. Notice how I add a 0 in the empty spaces when I'm moving my decimal. You got to do that too. All right, so my number becomes 3,200 in standard form. Now let's take a look at another example. This time I have 2.1 times 10 to the negative 2nd power. All right, so I'm going to take my factor, my coefficient, my mantissa, rewrite it, and I'm going to look at my exponent. What do we see here? A negative exponent. So that's going to tell me how many times to move the decimal in which direction? To the left, everything you own in a box, to the left. So I'm going to move my decimal 2 times to the left to move it with me. There goes 1 time, and there goes 2 times, and I'm going to put a 0 in the blank spaces when I'm moving my decimal. So here is my final number, 21 thousandths, or 0.021. All right, so you have practice problems that you can now go complete on Google Classroom. I hope this video was helpful. If it was, give it a thumbs up. And if it wasn't, ask me a question and I can answer it. All right, until next time.